First question, the CCl bond in chlorobenzene as compared with CCl bond in methyl chloride is either longer and weaker, shorter and weaker, shorter and stronger, or longer and stronger. So first we are supposed to know that this is a chlorobenzene. And this is methyl chloride. So we are talking about this bond in chlorobenzene and we are talking about this bond in methyl chloride. So now if you can see this in chlorobenzene, this bond acquires partial double bond character because since this benzene ring has a resonance, okay, there are lone pairs available on the chlorine and they form extension of the conjugation, and because of that it also shows partial resonance character. Now since it shows a resonance character, the bond length will become shorter, okay, and the bond becomes more stronger as compared to that of this carbon CH3Cl bond, because here we don't have any such resonance character or anything. So correct answer for this is shorter and stronger. So option C is the correct answer. Looking towards the next question, an alkyl halide may be converted into an alcohol by. So we need to look for all the possible reactions. So if alkyl halide undergoes addition reaction, this addition reaction is not possible, or there will be no reaction. Why? Because this alkyl halide is a saturated compound. So for the saturated compound, there is no possibility of addition reaction. Addition reaction is given only by alkene or alkyne, that is unsaturated bonds, and not by the saturated bonds. Now if I take alkyl halide as R, CH2, CH2X, okay, and I make the molecule to undergo dehydration or elimination in the presence of dehydrohalogenation or elimination. They both are one and the same because we are removing halogen from this carbon and a hydrogen from this carbon, that is a removal of HX group to make an alkene. So it is CH double bond CH2, okay, and the byproduct HX. So in this reaction we have removed this and we have created an alkene and not an alcohol. This reaction is dehydrohalogenation because we are removing halogen and hydrogen both, and this reaction is also considered as elimination because this HX is eliminated from the reactant. So in this reaction also alcohol is not produced. Only option left is substitution, and if I show the substitution reaction, that is an alkyl halide converted into alcohol just by the substitution by taking aqueous KOH. So this aqueous KOH hydroxyl group replaces this halogen to give you an alcohol. Okay, this is the only possible reaction where the alkyl halide can be converted into an alcohol, that is substitution. So correct answer is option B. Next question, the correct order of CX bond polarity is. Now in this carbon halogen bond there are three halogens, that is fluorine, chlorine, bromine and iodine, okay, where this fluorine is not usually used in the reaction, so we don't consider that. We consider chlorine, bromine and iodine, okay. Now down the group the atomic size increases, and because of the size increasing, bond length changes, okay. Other reason, down the group electronegativity decreases, and because of that polarity also decreases. The bond tries to become more non-polar as compared to that of this Cl, Br and I. So down the group, electronegativity decreases, and because of that, in the CX bond polarity will also decrease. So now if I say this carbon Cl bond will have the higher polarity than that of CBr and then that of CI. CI will have the lowest. So now looking at the options, which is having the chlorine as the highest. So here we have C and D, which have CCl bond as a higher priority. But then we have bromine. So it's there in only option C and then CI. So correct order of CX bond polarity is option C. CH3Cl having the highest polarity, then CH3Br and CH3I will have the lowest. Looking towards the next question, identify Z in the following series. So now we need to look for what the product will be formed over here in this chain reaction. So it's very simple that it is C2H5I, that is alkyl iodide. When it reacts with alcoholic KOH. Alcoholic KOH is a dehydrohalogenating agent. So it will remove iodine from one carbon and hydrogen from one carbon. It is like this, CH3, CH2I. So this I from this carbon and H from this carbon, and we are going to get CH2 double bond CH2. That is an alkene. So this is X. Now when this is reacted with bromine, double bond breaks and bromine get attached to these two carbons across the double bond. So there will be an addition reaction going on. So it will form these two Br bonds. Okay. So this is Y, 1,2 dibromoethene, and then it reacts with KCN. So when KCN reacts with this compound, it has a tendency to replace or substitute this bromine. Okay, so we get CH2 and in place of bromine we get cyanide group. This is Z. So looking towards the option which have this, that is CH2CN and CH2CN. So correct answer among the given option is option B. Next, looking towards the last question, benzene hexachloride is prepared from benzene and chlorine in sunlight by. So first of all, I'll write the reaction for you all. That is benzene and chlorine is reacted together. We need access of chlorine, or I can say 3 molecules of chlorine. Okay, this reaction is taking place in sunlight, that is HNu. Now chlorine in the presence of sunlight undergoes specifically an addition reaction. So how this addition reaction takes place? This double bond breaks down and chlorine gets substituted. Now suppose this bond will break down and we are going to get chlorine onto this carbon and this carbon. Then if this double bond breaks down, then we are going to get chlorine on this carbon and this carbon. And if this last third double bond breaks down, we can get chlorine over here and over here. So this is nothing but benzene hexachloride. So benzene hexachloride is prepared from benzene and chlorine in the presence of sunlight is by addition reaction. So correct answer among the given option is option C, that is addition reaction.